Hey guys, have you ever heard of Conway's Game of Life? So this is a simulation. It's a cellular automaton. Yeah, automaton. Basically, it's a simulation of cellular reproduction. And the way it works is that basically a cell is going to check to see if its neighbors are alive, and if exactly 2 or 3 neighbors are alive and it's alive, it'll remain alive. And if it's dead and it has exactly 3 neighbors that are alive, it'll become alive. But in the other all scenarios, it will die. So it's kind of a cool little game. And what I actually did is I built this like slide to kind of explain it. So let's pretend that we started off with a random grid of cells, and they're all black or white depending on their state. So think of a white cell as being alive and a black cell as being dead. Now if you pick a random cell like this one that I've highlighted for you, basically this thing is going to have 8 neighbors. So if you look over here, I've highlighted them in blue for you. So all of these right here are its neighbors. Okay, now you count how many of them are alive. So the black ones are not alive, so these ones are alive. So basically these 2 right here are going to be alive. So this one would have 2 neighbors that are alive. Since it's alive and its 2 neighbors are alive, and so it can have 2 or 3, and it will remain alive. So that will stay alive. Okay. However, if you look at a cell like this one right here, it has 1, 2, 3, 4 neighbors that are alive. So this cell will die. So now the grid size doesn't matter. I just chose 600 by 600 because that seems to be what I tend to choose on everything. So I'm going to go ahead and write this, and I'm actually going to use a 2-dimensional array, but I'm just going to use booleans. I only care if it's true or false. So just for fun, just for funsies, I'm going to use a boolean 2D array, and I'm going to set that equal to I'm going to let the computer randomly decide if it's true or false. So I'll let you decide how to figure out how to do that. And then I'm going to draw a grid of squares, and I'm also going to make a variable that will determine how many squares there are. So I could like make it as many as I want. So I'll start with like 10 or something, but then I'll increase it to 100 or even more. And we'll talk about all that stuff when we get done with this. But if you want to try this challenge on your own, go for it. Have fun, and I'll meet you back when we're finished. Okay, so just succeeded in creating the grid. So made a Boolean 2D array called cell state. I originally made it cell states, but then I realized that it's an array almost by definition. It has multiple cell states, so I took off the S. Anyways, only really needed 2 variables. I don't really need these, I guess, but I wanted to keep this flexible so I could like easily change the size, like if I wanted to make it a bigger one. So I just calculated the width. I could have made them fixed, but this way the size of my boxes will be dependent on how big the screen is and how many cells you decide to write. So if you did like a small number of cells, there would be big squares. It would fill up no matter what. Okay, so far so good. Then what I did was I of course just filled them. So this is a Boolean. So the way I decided to do it was I just let the computer choose a random number between 0 and 2. And if that number, remember random will be decimal, so it's not like only 2 states. It's not, but essentially it is, because I'm just saying if that number, I don't have to turn it into an integer. You could have turned it into an integer and say if it equals 2 or equals 1. Sorry, it will only equal 1 or 0. So anyways, if it's less than 2 or less than 1, sorry, then I just made it true. I'd have to find the other ones because by default all the Booleans will be false. So when this is first created, all the Booleans are false. And then I just changed some of them to true. And then in my draw function, there's only 2 things I'm doing in this whole simulation. I'm going to show the cells and update the cells. So I wrote the update cells first. Oh, sorry, show cells first, and I haven't written update yet. Obviously, that's going to be the hard part, but I just wanted to make sure it was working. So now, what we're going to do is we're essentially going to copy this whole thing for update cells. So just this double loop, it gets boring to write the same thing over and over again. So, but we are going to have to go through the whole thing. So we're going to go ahead and do this, and basically this part right in the middle is where all of the crazy stuff is going to happen. So what we're going to have to do is we're going to have to check the neighbor, and then what we're going to do is we're going to determine, we'll just say apply Conway's rules. Okay, so remember the rules are right here. If it's alive, so if it's already alive, then we can have 2 or 3. If it's dead, if its state is false, then we have to have exactly 3. So it's actually not that bad when you like break it down into just 2 rules, because really we're just worried about changing state. So if it's a dead cell and it has 5 neighbors, it's still dead. So it doesn't matter, we just leave it the way it is. So we're really only worried about which ones are going to change. So go ahead, try that, and actually I already see a problem, but I'm going to go ahead and make the same mistake because I didn't point it out, and then I'll fix it. Okay, so it works, kinda. I mean, it's working. Okay, so first of all, be careful for being overconfident. I should learn that someday. Anyways, it was a little bit of a problem for me to figure out what I had done wrong. So I thought the hardest part was going to be able to check all of these correctly. And by the way, I wrote them like this instead of putting it into the proper syntax. Whoops. This is how you would normally write an if statement. I wrote them in this compact way so it would be easier for everyone to read. And you should probably know by now that it doesn't make a difference that in Java, indentation, even pressing enter, unless it's in the middle of like this, if I press enter now, it usually doesn't make a difference. So if you want to just condense your code so that it's easier, since this is just a single liner, you'll see this sometimes, I don't know. Anyways, as a teacher, I tend to like always keep things spaced out, but in this case, I wanted to show all 8 neighbors. So these are 1, 2, 3, 4, 5, 6, 7, 8 neighbors. So I'm counting all of them, and I just wanted to just be able to show it all on the screen at the same time. So basically, I go through all the j-1s, and then I go through, there's only 2 j's because we don't count ourselves, so that's why there's 8, not 9. So we don't just count all the j-1s and all the j's and then all the j+1s. We take out the middle j. So for j-1, we go i-1, i+1. For j, we just do i-1, i+1. And then, because we're not going to do obviously I and j, we're going to skip that one. And then j+1, we do i-1, I, and I+1. So that pretty much is pretty self-explanatory. Don't forget to reset the counter equals 0. And by the way, I did declare this at the top, so I wouldn't have to keep declaring it each time. I guess you could have, though. You could have just made a new one. It doesn't really matter. I think it's better not to. So then, once we've counted up how many neighbors are alive, and it's kind of cool when you're using booleans, you don't have to say equals 1, you know, double equals 1. You just say if it's true, this is a true, it returns a true or false. So this is going to be either true or false. So the condition is the cell state. So you don't have to do any evaluation. It's just the cell state. So it's kind of an awesome, clean way. I like it personally. So then what I do is I check the state. There's two options basically. Either it's alive, so if cell state, so this is a live state, and the count is less than 2 or 3, we're going to change next gen. So what is next gen? So this is where I got really confused. Actually, this is where I didn't realize what the problem was, because my simulation originally was working okay, but not quite. So, and it was very interesting what was going on. So first thing I had to do was I realized that you can't just overwrite. I even said it in the beginning, but I forgot to do it when I was writing my code. So you need to first copy your cell states into its own next gen, I called it, state. So I just create a new array, copy all the values of this, because I'm going to use these arrays. So it was the same thing I was talking about. You don't want to check this and then change it before you check all of them. So what I did is I copied this, and then I changed each of these cells based on the original. So I just changed these cells like that. So actually, I can't believe I forgot to do that, but I did. So anyways, I fixed it now. So first copy the entire array, and then this is the one that I knew was going to happen, was the no pointer exception. And so that one, you just want to basically don't include the first column and don't include the last column or the top rows or bottom rows. So for each of these, I changed it from 0 to num cells to 1 to num cells minus 1. So anyways, that works pretty good. So, and then this is the part where it's going to be a little tricky is okay, so it works. So it's a little bit weird to do it. So first thing I did, let me actually take this part out and I'll just walk you through it because it's really cool. But the first thing I did was I condensed the rules from before into a loop. So it just will make it easier for everything. So what I decided to do was, instead of writing out each of these 8 conditions using all those variations, I'm just going to loop through. So I just made it 2 variables for how much we're subtracting. So basically, since we're going to go 3 by 3, since there's 9, and then of course that's going to double count myself, so I have to subtract if the state at the center is alive. So I subtract that one in case it gets double counted. So basically the idea is I only want to count the 8 neighbors. So if the center piece, which is ij, that's me, is a 1, I subtract that 1. So that's what this right here does. But anyways, the idea is that I go through the whole thing and check it. And if I do that, well, let's go back to putting this at 1. Okay, so this is the same way. So first it checks the same way, it behaves the exact same way it did before. Okay. However, now this is the big problem. We really want to be able to go all the way, check the edges. So we want to remove these 1s and -1. And the real tricky way of doing that is to use the modulus. So for example, if you're getting an out of bounds array exception of -1, an easy way to deal with that would just be to shift everything over by the entire length of itself and then divide it by itself. So for example, if there are 10 rows, right, then that -1 is a problem. If I had shifted all of those, let's say I add 10 first. Now all of those numbers would, instead of being from -1 to 9, what they would be is they would be from 9 to 19. Okay, so notice the key there that makes that different is that neither one of them is negative, right? That's first problem. But now the problem is we're out of bounds on the other side. And so what you do is you actually divide, or not divide, but you do the modulus of itself. So if the modulus was 10, 9 mod 10 would be 9. So that would put us all the way at the end. And 10 mod 10 is 0, so we go back to 0. And 11, and then it goes all the way through. And 19 mod 10 would again be 9. So it's actually really cool that that would actually solve our problem. So that's what we're going to do. So we're going to actually set these at 0. We're going to add the number of cells that there are, okay? And then all of this, that quantity, which could be any number, we're going to modulus it against how big it is. Okay, so that's going to return, that will only return numbers between 0 and 1 less than the number of cells, because that's how modulus works, and that's why it's genius. Okay, so anyways, it's a little bit tricky, but this is a trick. These kinds of things, whoops, add num cells. These kinds of tricks are the stuff that you're going to end up applying more than once, so this is definitely worth the conversation. So what's cool about this is now it doesn't have an edge. I mean, obviously it has an edge, but they're not behaving as any differently than they would if they're in the middle. So you may see the simulation go all the way through the screen. Of course, this thing's running itself out. But if you watch it closely, you can see that this thing does extend beyond through the screen. So sometimes it goes there, pops out the other side. It's kind of hard to see because I'm moving. You know what I can do? I can change this frame rate so you can see it better. So you can slow things down with frame rate. Let's slow it down. So default is 60, by the way. So if I do, this will be like 1/3 the speed. So we'll just slow it down a little bit. So you can kind of see that it is going through the screen. So here's a little interaction from both sides. The cells are dying, but that's generally what happens. I mean, these things can go on for a very long time, but generally there becomes a state where it's done, usually, I've noticed. But anyways, it's built, it works. Hope you guys enjoyed it. Feel free to play around now and crank up the heat to like 600 cells, and then you get, it's really hard. It's taking a long time. Let me change this. 600 cells is probably too many. Let's go ahead and put this, let's just take this out, leave it at full speed. I don't think it can go any more than that. Let's do, let's say 200 cells. That's a lot. Yay, look at that. Isn't that cool? Anyways, hope you enjoyed it. That was a little bit harder than I thought it was going to be, but it works. Ta-da!